Is Al Caballero with your Create Your Own Lab. Here's the video modeling. Here's the tracker showing how I track the ball's motion using an XY plane. The problem in my Create Your Own Lab was to see how gravity affects the projectile motion of a ball thrown in the X and Y directions. And the main result that I had from this was that the ball did model a projectile motion with gravity acting on the ball at all times. The ball started with an increasing motion on a quarter circle track upward, then reached its peak and began the quarter circle fall downward, and both are seen in the tracker graph and VPython. The object used was a lacrosse ball. The model relevant to the system are the force of gravity, the initial velocity being 2,7,0 meters per second, air resistance is negligible, and the momentum. VPython as a modeling tool. Here's my VPython as a modeling tool. I did change the width and the height to make the ball visible. I also changed the ball's velocity, which is a vector 2,7,0, so the ball would have an upward motion, then fall. And that's all that I changed, so I will run the code. You can see the ball in a projectile motion with the force of gravity working on it, and followed by the graph that also shows the motion of the ball from tracker. Connecting model to experimental data. From tracker, I use the points of data to show the projectile motion of the lacrosse ball thrown upward in the X and Y directions. I also included F-graph in the model to show the ball's normal path as seen in tracker. As seen in the graph in tracker, the VPython graph looks the same. The two graphs are shown below. As you can see, both have the curving of projectile motion and look to be the same.